Hey, what's up, everyone? So let's start with our lecture one, which is number systems and Boolean algebra. It's actually being counted as module one in Canvas for the online course. So let's just write module one here. Module one. It's a number systems. And so whenever you take any of the digital logic class or computer logic design class, we have to start with the number system and Boolean algebra, since this lays the groundwork for for all these subsequent contents being covered in this class. All right, so Boolean algebra we'll cover later, but let's get an introduction for the number system first. So for the number system, it's actually we are going to learn a 10-based number system, which we have been using in our everyday life, and also binary number system, which is a 2-based number system, and also some other systems being used in the computer. For example, hexadecimal number system, which is a 16-based number system. So these things are pretty important. When you are learning this, probably you won't be aware of the applications for these things, but finally you will find out these are something you must learn before you dive into any of the computer design project. So let's look at one example here, right? So for example, for the Arabic numerals, so there are 10 numbers in there. So they are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's no such a number, which is a single digit, to represent 10. So when you want to have a 10 here, you have to have a carry and then reset the first digit to 0. So actually there's no such a number 10 in single digit in Arabic numerals, right? So that's why we called this is a 10-based number system. All right, so let's think about that. 0 until 9, then we have to carry, right? So what about the 2-based number system? Think about it. What about that? So 10-based, we count until 9 and then we carry. So 2-based system will have 0, 1, and we'll never get 2 here. So 2 is going to be 1, 0 in the 2-based number system. The reason is we count until 1 and then we add 1 to the single digit and then we get a carry, then we reset the first digit into 0, back to 0. Okay, so this is called a binary number system. So actually, binary numbers are the only numbers the computer can understand. Okay, so that if you learn this further, you'll know that the reason we use 0 and 1 is because it's they represent 2 states of the computer system, which is on and off. So on is actually, you just turn on the switch. 0 is off, which is you just turn off the switch. And you have billions of transistors in a single CPU or a single digital chip, which are just billions of transistors, actually billions of switches, which are being turned on and off to represent a digital status over there. All right. So this is two-based number system. We count until 1, and then we get a carry, and then we reset this number, this first digit to 0, right? But here we count until 9. Here we count until 1. Now let's take a look at a different number system. For example, 3. What about this? What about the 3-based number system? You can imagine that we will have 0, 1, 2, and actually the number 3 in the 3-based number system will be 1, 0 instead of 3, since you don't have 3 in the 3-based number system, right? Now you're wondering, so what is number 4 in the 3-based number system? Can we have a 4 to be represented in here? So the answer is yes. You can have billions or whatever you want using any of these number systems. You just use a different strategy to have your carry. So that's the only difference between these number systems and the 10-based number system. We have been very used to the 10-based number system, but actually, nobody tell the human beings to use the 10-based number system. It's just some people say it's really very likely that because we people have 10 fingers, that's why people have been used to whenever they count until 9, they want to carry, so they want to use a 1, 0 like this. But actually, nobody tell us to do this. It's just like we are very used to a 10-based number system in everyday life. However, you can use any of these ones if you like. So for example, the computers are using a 2-based number system, which is also called a binary number system. So that's the only a number a computer can understand. Okay. So you can also have a 3-based number system, but however, it's 1, 0, 1, 2, and this is 3. And if you want to have a 4 here, it's going to be 1, 1. You're adding a 1 to this digit, right? If you want to have so that's a 0, 1, 2, 3, 4. So 5 will be 1, 2. Okay. Why is that? Because when you have a carry here, this 1 here represent 3. So 3 plus 2 is going to be 5, right? So in the 3 number system, this is how we count different numbers, how we represent different numbers in here. So what about 8 based? So this is also called octal number. Okay. So we will have 0, 1, 2, 3, 4, 5, 7. So for 8, we won't have 8 here. So it's going to be 1, 0 will be 8, and 1, 1 will be 9. All right, then so on and so forth. Okay, this is how we use the existing Arabic numerals to have different types of number systems. The only difference is you just carry at a different number. That's it. Instead of have a carry after 9, you carry after 1, after 2, after 7. Right. So this is kind of just give you an introduction. However, we're going to have more examples. I'm going to summarize everything, all the important numbers, into one big table for you. Now, All right, now let's take a look at all these number systems. So now let's summarize everything in one table, okay? So the first one definitely is going to be the 10-based number system, which is also called decimal. And the second one is 2-based, and it's called binary. And the third one is 8-based, which is called octal. The last one is 16-based. It's called hexadecimal. Right. So let's start counting these numbers. So definitely we start from 0, and next number is 1, then 2, 3, 4, 5, 6, 7, 8, 9. So after 9, definitely there's no such a number 10 in single digit version in the 10-base number system in Arabic numerals. So we have to reset this digit to 0 and then get a carry here. So it's going to be 1 0, which is, we call it 10, but actually it's just 1 0. Okay. And then 1 1, 1 2, or 13, 14, 15, 16, 17, 18, 19. Right. Let's just stop here. Now I'm gonna write down all these binary numbers in for these numbers in the binary version in this column. So 0 in binary is also 0, because it's making sense since 0 at anywhere is going to be 0. It's not making sense like you have something here and you have a 0 here, or you have a 0 here but you have something in this number system. 0, just 0. If you have nothing, you have nothing anywhere else as well, right? So 0 0, 1 1. However, you do not have this 2 in a binary number system, so we have to figure out how to represent 2 in binary, right? So it's actually we are adding 1 to this digit and we get a carry, then we reset this digit to 0. If we write it down here, it's going to be 1 plus 1. In binary, it's going to be, we have a carry here, we reset this digit to 0 and we get a carry. So it's going to be 1 0, will be binary. The 2 in the binary version, right? It's going to be 1 0. So for 3, we just need to add 1 to 2, right? So add 1 here, it's going to be 1 1. Now what about 4? So if you have a 1 1, which is 3 in decimal, you add 1 to 3 in decimal, we know it's going to be 4. However, in binary, we need to carry here. So we reset this digit to 0, then we get a carry, then carry is 1, add 1, you have another carry, then just write it down here. So we finally have 1 0 0 for 4 in the binary version. So for 5, it's going to be 1 0 1, you just add 1 to this digit, right? So 6, you add 1, let's write it down here. It's 5 plus 1, right? We know it's 6 in decimal number. And in binary, we carry, we reset this digit to 0, then we get 1 plus 0 is going to be 1, then 1, so it's going to be 1 1 0, will be 6 in binary. Okay. 7 will be 1 1, 8 will be, that's a tricky one, right? So 1 1 1 plus 1, it's actually 7 plus 1, we know it's 8, right? But how does that look like in binary? So 1 plus 1 is 0 and carry, and then 1 plus 1 is going to be 0 again and carry, and 1 plus 1 is going to be 1 again and carry. So it's going to be 1 0 0 will be 8 in binary. So 9, you just add 1 to it. And then 10, same concept. You reset here, you get a carry. 11 will be 1, 0, 1, 1. Just add 1 to it. So 12, you add a 1 here, then carry. So finally, it becomes this. 13, you add 1 to it. 14, 15. So now, same concept. So when you add 1 to 1, 1, you get 1, 0, 0. When you add 1 to 1, 1, 1, you get 1, 0, 0, 0. So now same concept. When you add 1 to 1, 1, 1, 1, you are going to get this, right? So 17, 18, 19. And of course you can keep counting, but we don't want to do it anymore. So now let's look at the octal number system. So definitely you have 0 here in 8-base number system, no problem. You have 1, you have 2, you have 3, you should have 4, you should have 5, you should have 6, you should have 7, but you don't have 8 here, right? If you don't have 8, but we still need to represent 8, so that's why after you add 1 to 7, you are getting a carry here and then reset this digit to 0. So you are getting 1, 0 is going to be number 8 in the octal number system. And then 9 will be 1, 1, 10 will be 1, 2, 11 will be 1, 3, 12 will be 1, 4, 13 will be 1, 5, 14 will be 1, 6, 15 will be 1, 7. Now we have the same problem here. We do not have number 8 in there, so after 1, 7, we have to use have to carry to this digit. So it's going to be 2 here right now, and we reset this digit to 0. And then to 1, to 2, to 3. So you can, when you have these kind of numbers in the octal number system, you cannot call this like 13, 14, 15, because whenever you see that, you are telling people you are using the 10-base number system. So in octal number system, you do not have 14 here. So the name of this number is going to be 1, 4 in octal. The same concept here. So when you have this, it's not 1,000 in binary, right? It definitely, because it's not in a decimal number system. So the name of this one in binary is going to be 1, 0, 0, 0. You have to, say it out for every digit. Now let's take a look at the hex number. Definitely you have 0 here, you have 1, you have 2, you have 3, you have 4, you have 5, you have 6, you have 7, you have 8, you have 9, you have 10. But the problem is, since we are trying to reusing, or you can say recycling, the Arabic numerals from 0 to 9 here as the symbols to represent all these numbers, but we are out of symbols right now, because for the 16-base number system, we're going to have up to, this is from 0 to 15. It's actually 16 numbers in there, but we only have 10 numbers in the Arabic numerals. So we have to be more creative. We have to use something else to represent a 10 here in a single digit version. So we cannot do this. So people use A for 10, and then people use B for 11, then C for 12, then D for 13, then E for 14, and F for 15. Okay, so that's actually 10, that's 11, that's 12, that's 13, that's 14, that's 15. Okay, so now what about 16? And you do not have 16 in the hex, in the 16-base number system. Same concept. You don't have 10 in 10-base number system. You don't have 2 in a 2-base number system. You count until 1. You count until 10 and 9. and you count until 7. So you count until 15. So 16 here will be something else, right? So when we are adding 1 to F, you have to carry and reset this digit to 0, and you get carry, right? So it's actually 15 plus 1. We know it's 16 in the decimal system. However, in a binary, in the hex number system, it's going to be 1 0. So 16 will be 1 0. 17, 18, 19. Okay. Now let's think about another example here. So what about 32 decimal, or 31? Let's say 31. So what's the number here in hex for 31? Think about it. So for 31, since if you have a 1 here, it's going to be, so this is number 16, right? So what about you have a 2 here? If you have a 2 here, that will be 16 plus 16, right? So if you have a 2 here, 2 0 in hex, it's going to be 32. However, we're asking for 31. So what you need is use this one to minus 1. So you are getting 1F. So 1F, because 1 represents 16, F represents 15. So 16 plus 15 will be finally 31. So that's just one single example to show you how you can use a hex number to represent all these numbers we have been used in decimal number system. Okay. And now let's pause here, and I'm going to give you some homework assignments to practice on these number systems, and I will see you in the next video.